Chapter 14, Exercise 16, is asking you to draw the amide formed in each of the following reactions. And just to recap, an amide is a functional group where you have a carbon double bonded to oxygen, single bonded to an amine. That altogether is an amide. Now here, you can create amides when you react a carboxylic acid with an amine. And these are important reactions because this is how amino acids, the carboxylic acid end of one and the amine end of the other, connect to form a long chain of proteins. Okay, so how does this work? How do these two connect to each other when they do connect? First I'm going to redraw these as a skeletal structure, and so I'm just going to count up the number of carbons. I've got 5 there, so let me say 1, 2, 3, 4, 5. This one at the end has the carboxylic acid. Let me draw that OH. And then the amine, and I'm going to draw the bonds to hydrogens individually. So you have those and this here. So when these two come into contact, the OH and the H leave together as water, HOH, which is really H2O. So those leave. And the bonds that used to go to those two things instead connect to each other. Now you wouldn't want to leave your answer like that, with that long, crazy bond, so instead you redraw the molecule just with a shorter bond to the nitrogen. And that would be your amide. You know it's an amide because you have the carbon double bonded to oxygen, single bonded to an amine right there. All right, same idea. The only difference here is going to be the carbon chains coming off of the carboxylic acid and the amine. So I'm going to redraw these first. Here I have 1, 2, 3, 4. So let me draw those. 1, 2, 3, 4. Off of carbon number 3, I have a methyl group, this methyl group coming up. So I'll put that coming up. And then on carbon 1, the double bond to oxygen, single bond to OH. So that's that molecule. Then the amine. On this amine, I have 1, 2, 3 carbons coming off of that nitrogen. So 1, 2, 3. Right? 1, 2, 3. And coming off the nitrogen needs 3 bonds, so it's going to be 2 more. I'm going to draw the hydrogens individually. And so when these two molecules come into contact, the OH on the carboxylic acid, combines with the H on the amine and forms H2O, water. And so it leaves as water. And the 2 bonds going to those things instead connect to each other. You don't want to leave the molecule like that. Redraw it with a more reasonably sized bond. And there you have your amide, or amide. All right, same idea here. The only difference, again, are the carbon chains coming off of the carboxylic acid or the amine, but the process is the same. So let me draw each of these in its skeletal structure first. So I've got 3 carbons there. That would look like that. On that first carbon, double bond to oxygen, single bond to OH. Let me actually put that in a different color. And then on the other one, we have a nitrogen. It has a benzene ring. If you remember, the common name for this is aniline, but you wouldn't be expected to know that. And so there you have it. These are those 2 molecules. Now, when they come into contact with each other, the OH on the carboxylic acid and one of the H's on the amine leave as water, H2O. And the 2 bonds going to those things instead connect to each other. Now you wouldn't want to leave the molecules like that. You'd redraw it with a more reasonably sized bond, and you'd have this amine, or I'm sorry, this amide as your product. That would be the amide, or amide, formed from that reaction.